Hello, everyone. Hopefully everyone can hear me and see me clearly. Okay, so now, hello, everyone. Welcome to today's webinar, focusing on 5-factor online identity verification for efficient risk management. My name is Teresa and I'll be moderating the session. The webinar is intended for product managers, system integrators, and also developers. During today's webinar, we'll be talking about the secure identity verification, abolishing the risks, and preventing the fraud using Innovatrix solution called Digital Onboarding Toolkit. The solution is designed to leverage facial recognition to match an end user's face against their image on an official identity document. The webinar will be divided into 2 parts. The presentation that will take approximately 25 minutes, and the Q&A session that will be open for maximum 15 minutes. As usual, you're more than welcome to take an active part in this webinar. You can ask a question anytime. We will collect the questions during the webinar and address them immediately in the Ask a Question tab. For more complex questions, we will be addressing during the Q&A session at the end. You can also post your questions via email, writing us at webinar@innovatrix.com. You can find all answered questions at the Ask a Question panel in the section Answered. Again, most popular and complex questions will be answered by Daniel at the end of the session. There is no need to take notes. We will be sending to all attendees the follow-up email where you can download the recording and the presentation at any time. In case you feel you need to discuss some of the topics addressed today in more detail, please see Call to Action tab that will appear on the bottom part of the screen. You can as well write us at sales@innovatrix.com or contact directly your sales representative at Innovatrix. Finally, I'm happy to introduce our speakers today. Head of Product Management, Daniel Ferak, will be talking about how to use Digital Onboarding Toolkit for online identity verification and remote onboarding of clients, following with explaining the ID detection, classification, and OCR recognition, and some other additional features. We have also present Regional Manager for EMEA region, Donald Green, who has multiple experience with DOT and customers. Sorry. Before I pass the word to Daniel, I'd like to ask you to join the poll on the bottom of the screen to help us understand the audience today. Thank you very much and enjoy the webinar.
Okay. So welcome everybody. Hopefully you will find this presentation useful. Let's start without too many words. Just maybe a little bit about Innovatrix. Innovatrix is on the market for 15 years already. We've done really many projects worldwide, more than 500 in more than 80 countries all over the world. We usually claim that basically through our systems, we already enrolled more than 1 billion enrollees using biometrics. We support all 3 biometric modalities, meaning fingerprints, face, and iris. Just a little bit about the product portfolio. The core or flagship product is Innovatrix ABIS, which is focused on large-scale biometric database systems for basically the biometric identity management. SmartFace for the real-time video streaming processing. Currently, the main use case is the CMOS access control. And of course, our SDKs that are in the heart of all our products. We focusing mainly on the OEM solutions and Digital Onboarding Toolkit, which will be the main focus of this presentation. So let's jump directly into the presentation. I will be talking more about the online identity verification in context of the product that our product Digital Onboarding Toolkit, which can be used for this use case. So what is actually the online identity verification? Why do we need it? So let me, Jane, standard girl, she would like to claim her identity for a service provider. Service provider can be, for example, a bank or telco, or really anything who wants who Jane wants use service from. So traditionally, of course, she could go to the service provider directly and display her ID, but this is not what Jane really wants to do. She is a young millennial. She wants to do everything using her mobile or a laptop at worst. Or maybe she's an elderly woman during lockdown, and in these days it's really too risky for her going out. So the remote or online identity verification is really a convenient way on proving her identity. What she really needs to have is, or the only thing actually what she needs to have, or what these two things like laptop and mobile have in common, is a camera and of course the internet connectivity. So that's, in terms of hardware, really the only things she needs. And it's really important that in terms of user experience, the whole process of the online identity verification is as seamless as possible. The whole process really takes just few minutes, and it consists of several steps. I will talk about those in more detail later. For now, really just quick overview. Of course, Jane or whoever needs to take a picture of her ID, confirm the data which were extracted from the ID, take a selfie, and prove that she's alive, she's not spoofing, and basically that's it. That's, from her point of view, end of the story. Of course, from the service provider point of view, there are things that needs to be cared of if they can, so they can really be sure the identity was really proven correctly. So I will talk about the 5 factors for identity verification, which Digital Onboarding Toolkit can be used for, and these are ID data extraction. So first of all, we need to somehow extract the data from the ID. Then the ID authenticity, meaning we need to somehow validate the data are valid, not faked. Face verification, so basically comparing face from the ID with the selfie picture. Liveness check, meaning we have to prove we are a live person and not just a video. And biometric deduplication for fraud prevention.
Yeah, so I will just add a few comments throughout this presentation from the field, basically from my experience of working with clients in actually rolling out this technology and bringing it to life inside their projects. So first of all, hello to everyone. I hope you're all staying well and safe wherever you are in the world. So personally, I've been involved in quite a few rollouts of this technology over the past 2 years. And I would say my single biggest takeaway is that really no 2 projects are the same. Even when you work with the same customer, we found that the use cases and even the requirements can vary significantly from country to country. One of the largest rollouts that we've had so far of Digital Onboarding Toolkit is with one customer, the same customer, but across 4 different countries in Asia. And annually, we're onboarding with that customer about 20 million new customers of theirs per year. And because of differences in things like business model, local customer preferences, and even and especially the regulatory environment, we found that the way the technology is actually set up in those different countries is vastly different. So that's why we realized at a very early stage of rolling out this technology that the key would be to keep it as customizable and configurable as possible to cater for all the possible use cases and all the possible user workflows that would be required. So I think Daniel and his team have managed to achieve that and do a good job at keeping the technology configurable. And I think that will be demonstrated throughout the rest of the presentation.
Exactly. Thank you, Donald. So now let's dig into the details, into more details about what I mean by these 5 factors. So, as I said, it all starts with the ID. It might look like a simple task at the first sight, but there are quite a lot of challenges behind the scenes. So first of all, of course, there are plenty of different ID formats out there. So we need to somehow cope with it. But at the very beginning, from the technology point of view, we need to understand what is in the picture, whether it's actually an ID or not. And it's really interesting technology behind this. We use neural networks or artificial intelligence for most of the tasks that I will be mentioning throughout this presentation, and some advanced computer vision techniques as well. So first of all, we need to detect the ID in the picture, making sure that we are really looking on the ID, and we need to do the perspective transformation of the image. So it's not skewed as like you can see here on this picture, but normalized, so we can make advantage of the annotated documents that we have in the database. The second challenge is to understand which ID we are looking at. So which ID we want to recognize, we want to read the data from. We use feature-based template matching for this task, and we call it like auto-classification of the ID. And the main advantage from the user point of view is, of course, that they do not need to choose manually what ID they want to get recognized, and it's just on the system to understand or to correctly classify the image that we are looking at, or that we want to prove our identity with. So these are the first 2 important tasks. The next one is actually the data extraction, or reading the visual data that are on the ID. As I mentioned, we have a quite big database of annotated document. We can really scale this up, and that's really important when we want to support a new type of documents or new customers requiring special documents. That for us, it's basically just about the picture annotation of one sample document that we want to get recognized. And our latest version of the toolkit, we really can do some advanced OCR recognition. We just need to train font that is used on the ID that we are annotating. And again, there are some neural networks behind the scenes that are taking care. And you know that for the neural network, we need a lot of data in order to get a very good accuracy and good results. So the real trick is here that we can generate these data automatically without having the real IDs for the training, but really just one sample ID. We can generate based on the font that is found on the ID, really many or large data set for the training. And you can see the examples of what does it look like for the neural network, what we need to train the neural networks on the right side of the image, just to get some insight into what we are doing. Of course, the ID is not just about the visual data. Many IDs these days are equipped with the NFC chip. So the toolkit is able to read the data from this chip. Usually we can find the actual biometric on the picture from which we can extract the biometry of the person, which is great, and some other data as well. Most of the IDs, of course, contain the so-called MRZ, so machine readable zone, which is specifically meant for reading by machines. And some of the IDs also contain barcodes. We support all these three things where we can find the data, and that can be very useful for cross-checking the data with what we have find in the visual zone and what we extracted with the OCR technology. So that's about the first thing that we can how we can validate the data. And then we have some other quite advanced techniques for another security checks. I can show you the thing that we can, again, we use neural networks for, and it's age and gender estimation. So you can see this was a real try for fake identity verification, and you would be surprised how easily we can find that that's the case. So first of all, the expected age of the person would be 31 years based on the date of birth and the date of issue of the card. And the expected gender would be the female, which is stated on the card itself. And thanks to our neural networks, we can estimate the age and gender from the picture itself. And you can see the data is different. Mainly the gender is fairly different, so it's clearly very suspicious. And of course, then there are security features. And I will be honest here, having only the camera for some kind of advanced heuristic and security checks and validity of the document is really a hard task, but we are really working on it. We have some nice ideas, and we are currently focusing on these three things. So basically matching the position and shape and color profile of the security features that are found on the IDs. Then the photo tampering, which again we can use neural networks to detect whether there are some suspicious like really strong edges of the photo and similar things that are clearly indicating a fake ID. And of course the fonts, which, as I mentioned already, we we train specifically per ID document, or actually the version of the ID document. All right, the next factor, of course, is the face verification. So clearly, we need to confirm that the person who is taking a selfie is the same one as the picture on the ID. This is my current picture, and this is me 10 years younger. Still, as we have one of the best performing biometric verification algorithms in the world, confirmed by NIST, even pictures of such a poor quality, as you can see here, with such a time difference in terms of when the pictures were taken, can be used and can be used with really high accuracy for one-to-one face verification. Next factor is something what we call liveness check. And of course, there are two approaches to this thing. One is so-called passive liveness check. What does it mean? It means user doesn't need to do anything basically, and maybe the user probably even doesn't know that there is something in the background with what we call what is checking the liveness of the user. So can you spot the difference between these three pictures? Clearly, there is some difference, and hopefully you can see it over the streaming. But I can help you a bit. The first picture is taken from a screen of another device, meaning either a screen, laptop screen, or another phone. The second one is a picture of a printed face, and only the last one is really the original photo of this girl. And what we are doing, of course, we are training the neural networks to spot these differences, so we can evaluate whether what we are looking at is a real person or it's a attempt for a spoof. Another approach to the same problem is so-called active liveness check, where we actually encourage the user to take some specific actions. Our toolkit, we were really trying to find something that can provide the best possible user experience, not without too many distractions of the user, but still fairly accurate. And we came up with this approach where the user needs to follow the dot which is moving on the screen. You can see again there are different positions, random positions generated. The user moves with his eyes to follow the dot, and again we train neural networks to spot the differences in terms of the eye position.
Yeah, maybe just to mention, the topic of liveness is another area that we really got some great lessons and managed to adapt based on the feedback from our customers. So on one hand, you have the active liveness, which Dano just showed, in which the customer actually knows that their onboarding is being challenged and they have to perform an action in order to get to the next step of the onboarding process. And this was pretty much well received all around. But one particular case we found was that some customers where instead of actually following the dot moving on their phone screen with their eyes, they were moving the phone in the same direction as the dot. So this was an interesting piece of feedback that we got, and we had to sort of take that into account. Then we also have, the passive liveness approach, which Dano mentioned as well, which really is something groundbreaking. It's a recent development, meaning that a trained algorithm can give a liveness score based on just one single image. So the user doesn't need to perform any actions. And many customers loved how seamless this was, not to mention it also being very secure. But some other customers said it was almost too seamless. and they would prefer in their workflow that the user actually did have to perform some sort of active liveness challenge. So of course, the benefit of having both approaches is you can easily use both of them at the same time in the same part of the workflow. And the combination of the active and passive liveness actually gives you the highest level of presentation attack defense.
Yeah, thank you, Dono. Okay, and probably the last factor that can be used for identity verification is the biometric identity management system that I was mentioning at the very beginning. Basically, the whole digital onboarding or all data from the identity verification can be fed into the identity management system. And very important step is then the biometric deduplication. So checking whether the same face was not used with in context with a different ID, which might indicate a fraud attempt. And I'm sure Donald can again have some comments on this.
Yeah, so the biometric identity management system is really an adaptation from the Innovatrix ABIS, which has been our core product for quite a long time. So this is like an ABIS which is tailored to the onboarding use case and works very well hand in hand with the onboarding technology. It's something which really has unique value, especially when we talk about customers who have a large number of attempted onboardings. So in standard scenarios, we go through an onboarding workflow, and if the onboarding is rejected, we simply discard that data, or maybe we do store it, but we usually don't use it again. So with this biometric backend, for example, our customer in the Philippines is able to, in real time, check the face of each person attempting to onboard, but not just do a one-to-one against the ID card. They can actually check that face in real time against, in their case, 8 million other faces of people in the database who have previously attempted to onboard. Then if there's a hit, they can use that data associated with that onboarding to inform their decision. So one of the best benefits of this is, of course, that it allows you to catch people who have previously attempted to onboard under a different identity, and you can simply and immediately reject their onboarding attempt.
Exactly. Okay, and that's pretty much it. So just to repeat all the key points from the presentation. The digital onboarding toolkit allows for really 5 factors identity verification. First of all, we need to extract the data from the ID, both visual parts and machine readable zones, barcodes, or NFC chips. Then we need to somehow cross-check all the data that we extracted from the ID, do some advanced heuristic for the authenticity checks. Then we need to do the face verification, so one-to-one face from the ID against the selfie. Then liveness check, and the last step is of the puzzle is the biometric deduplication. Okay, so that's pretty much everything. But I would like to show you also the real-time demo of the toolkit. So finger crossed, everything will be working as expected. All right. So I will just show you the. Hopefully you can see the screen of my testing mobile device. I will open our demo application, which serves as a very simple use or a demonstration of a use case when a user or a potential client wants to enroll or wants to create or get an account in a bank. All right, so steps that needs to be done, as I mentioned. First of all, we need to scan the document. Do not need to choose the type of the document, as I mentioned, because that should be classified automatically. You just need to make sure the picture is okay. Now the data is extracted in the background. And as you can see, these are basically all the data that can be found on the ID. The user really doesn't need to do anything, no need for typing of the ID document numbers or date of birth. Just press all correct, everything is all right. Now, of course, the face capture part. And voila, that's it. You probably didn't even notice there was a passive liveness check behind. You might not even believe me, there was something like a liveness check going on. So I will try to prove that there was. And I will do that by signing in back into the application, where again we have the liveness check implemented or integrated. So I have the account created. I am already the bank client, and now I'm signing into the app, and that was me, of course. So I got through. I'm now in the banking system. I can check my account. There is really like this cool feature. If I'm not looking at the screen directly, you can see the screen is blurred. Again, I'm back. You can see everything is again readable. So we can continuously do the face verification. It's a really fast operation, even on the mobile device. And we can do it basically in real time. Okay, now back again. Let's try to do the fake sign in. So I will use my printed picture from today. So really the same, pretty much same face as I was using just second before. And let's try it. Okay, so that's it. As you can see, liveness check failed, meaning that was a fake attempt. Another similar use case is to use a picture from a different mobile device. So let's do that. Again, the same story. Now back again with my real face, and see, fast, almost instant, I'm in, I can use the service. So that's all for today. Thank you very much.
Thank you very much, Daniel.
And of course, if you have some questions, I'm here for answering them.
I would perhaps add one final comment just to close it off.
Sorry.
I think it's important to say that despite the fact that we've called it DOT or Digital Onboarding Toolkit, we do and we have seen many other use cases where this can be applied outside of onboarding.
Sure.
For example, in things like border control, where people can use their passport and a selfie in order to check in for a flight, and that can be done, in the taxi on the way to the airport. And when they get to the airport, because they use the biometric backend, their face then becomes their token to move through the airport seamlessly and board their flight. Also, things like ride-sharing apps, where it can be used to increase the trust between drivers and passengers, knowing they have verified identities. And even very simple use cases like when you receive a new credit card from your bank. So in our scenario, the credit card would only become active when you actually log into your banking app and confirm receipt of the card with your face. So as I mentioned at the start, by keeping the toolkit flexible and configurable, we can really apply it to pretty much any situation where somebody needs to prove their identity.
Thank you very much, Daniel. Thank you very much, Daniel. I'd like to ask you both to stay with us for a moment, because we can see that we have kind of a discussion right here. We have some very, very nice questions asked from our guests. So I'll suggest let's move right into them if you have nothing else to say. And thank you again for your presentations. And the first question that we have there is, and feel free, anyone, any of you, answer. For Ambit Systems, what plans you have? So that might be maybe Daniel.
For
Answering.
embedded systems, what plan you have?
Yeah.
Okay. Of course, the toolkit itself can actually be used also to be correct, the underlying SDK, which the digital onboarding toolkit is leveraged on, can be used also on embedded devices. We actually have customers using this low-level SDK, and but it's really for like large OEM deals, and that's not a plan. That's already a current reality.
Okay. Thank you very much, Daniel. I'll try to choose another one that seems like one of the most popular. And there's a question from Leon from Luxembourg. Hi, Leon. Do you have a Java API that we can submit a passport photo on, and it will extract photo from MRZ info? That's probably as well for Daniel, or anyone. Feel free to answer.
No, the MRZ zone doesn't contain the picture information. It only contains the data from the text, or the text fields, basically. So that's not possible.
Okay. Thank you.
Okay, but of course, the API that we provide can be used for extraction of the photo from what have been detected on the picture itself. So that's not a problem. So hopefully I answered the question.
Great. Thank you. There is another very interesting question regarding the video and the liveness check video that you just showed us. How can you prevent the system being fooled?
I think the simple answer is that we train the algorithm for detecting these types of presentation attacks on really huge amounts of data with really millions of data points. And over time, the algorithm learns to understand what is and what isn't a genuine onboarding attempt. So the ones actually like replaying video clips, especially if you use a standard screen or a mobile phone screen, are quite easy to detect with high accuracy by our algorithms. But it's always a question of things like where you set thresholds and the amount of data the algorithm is trained on. But in these cases, we would be quite successful in detecting these types of attacks.
Thank you very much, Donal. Once we have you online, there is an interesting question on you as well. Do you have experience with interesting use cases for the insurance industry?
Okay, so two parts to the question. Are they in the insurance industry, and are they interesting? I think well, every use case is interesting because they're always different and every project is different. I wouldn't comment on individual cases, but we do have customers who provide insurance products, and they use pretty much the same onboarding workflow as Dano has showed for verifying the identity of customers and where customers can log into their applications.
Great. Okay, and let's say 2 more questions so we don't keep it too long. Okay, can you fool the liveness check by replaying a video clip? Daniel.
I think we've addressed that question already a couple of seconds
ago.
Sorry,
I that's true.
That's hear you quite well. Teresa, could you please repeat the question?
Yeah, but Donald just pointed out that we've answered the question, so let's choose another one. Does OCR works for different kind of alphabets?
Yeah, it does. Actually, as I mentioned, that we can train the specific fonts for the OCR, and we currently have support for Latin alphabets, Cyrillic, and currently what we are focusing on is Arabic. So hopefully very soon we can support also Arabic OCR.
That's great. And the last one. Okay. Do you guys have worked before within immigration security to detect fake passport and other frauds?
Yes, we do have use cases in that area, although because those things are quite closely connected with things like national security and those kind of things, we wouldn't mention specific cases, but all of the things in the SDK can be easily adapted to from the banking use case, which we presented here, into things like immigration and border control, especially in places where you have border crossings, for example, with no electricity. And the border guards are using mobile devices to actually check people's documents as they cross borders. So by having a tablet or a mobile device with Digital Onboarding Toolkit on board, they could easily extract the data from somebody's ID card or passport and then do the selfie to verify who they are. So depending on the use case, there's definitely a place for this in the border control ecosystem as well.
Awesome. Well, I know that I said that we shall be done, but we have a lot of questions in here. So guys, you tell me, what do you feel?
No, let's
Can
keep
we
them
look up
coming
more?
for sure. Let's keep them coming. Yeah.
No problem.
Okay, so let's do it. I'll choose another one. The OCR works with any country ID for digital onboarding. A few seconds ago.
Okay, so
yeah.
So that what I was mentioning at the beginning. We can currently we do not support all IDs in the world. That's the current status. But the really nice feature of our technology is that we can basically add support of any ID cards in almost like no time, meaning we need maybe 2 days for training of the phones, for annotating the documents, for generating the data that are needed for the neural networks, and integrating the so-called metadata into the kit. So it's quite straightforward for us to add support of any required documents.
Great, thank you. There's another very interesting question from Stefan. Gender ethnic. How do you handle the heterogeneous relaxing specification on biological, psychological gender notation in documents? And there's also a sub-question. How do you process ethnic discovery? Matching against what? Who dares?
The first question is an interesting one. I guess it really comes down to the specific country we're talking about, their specific ways of handling those situations, and what they actually print on the ID card. I think our solution doesn't go too deep into that. It simply reads what's written on the ID card. So if it says male, it says the person's a male, and does a gender estimation on the image based on that. And if it says female, it does the same. Of course, there probably are a growing number of cases now where you have different things printed. And honestly, we haven't come across those types of situations yet. But if we do, we're definitely willing to address them and adapt the technology accordingly.
Exactly. And maybe also important thing here is, again, the whole process here is configurable. This is only one of the many factors that needs to be taken into account when evaluating the risk of a specific onboarding or identity verification. So in this particular case, there would be like no data that could be considered, but still there would be quite a lot of other data that on which we can build the identity verification.
Great. Let's move forward. Just let me know whether we already answered this, but what can you provide for morphed overlaid Photoshop picture detection? That's also from Stefan, the question.
Well, it depends. Of course, if and I mentioned that I'm very honest here, and I do not want to say something that is basically not true. So if there is a fake that is really that a real human would not be capable of recognizing from a real ID, we could not cope with that. That's the current situation. But it's only one of the factors that are coming into the whole puzzle. So that always needs to be considered in the context of all other factors. We are also thinking on really interesting ideas on how to add even more factors that could be evaluated, which again can help the online identity verification process in terms of security.
Great. Donald, there's a question for you. How does active compare to passive liveness detection?
Well, it depends in what you mean in terms of how does it compare. If we talk about in terms of the user experience, of course, one is completely seamless and one requires the user to carry out an action. In terms of accuracy, they're both they both have their advantages and disadvantages, like I've said, and it really depends on things like how you set up the thresholds for the confidence scores. But the ultimate in use cases where you require high levels of presentation attack defense, the ultimate solution is to use both combined, essentially having two different factors taken into account for proving liveness. But as you've seen with Dano's presentation or Dano's demonstration, although it's a relatively new technology from us, it does work very well. We've done tests on hundreds of thousands of images and the results are quite positive. This is the thing though, it always depends on your data. So what we would say is if you'd like to try it on your data, get in touch with us. We'll give you the SDK and you can try it on your own data.
Great. All right, and let's do the last question for Daniel here. Sorry, it's disappeared for a second. Can I use the SDK for web apps, or is there a web component to use?
Yes, sure. We provide like complete integration package, which includes also the samples of how to use the whole toolkit only from the web. So yes, that's possible, and we have a package for integrators that are interested in this scenario, this use case.
Awesome. Well, Daniel, we have a challenge here for you as well. I don't know whether you mentioned in the chat box, but someone would like to see the liveness check again, whether it's possible to play the game. So let us know whether it's possible, and I would actually finish the discussion with this. What do you think? Is it okay?
Yeah, let's go ahead. So
okay.
Let's try.
Well, thank you, Donald. Thank you, Donald, very much for now.
Thank you very much.
See you soon again.
You're welcome. Thank you.
Bye. And Dana.
Okay. So as I mentioned earlier, I already enrolled into the system, so I can showcase the liveness check during the sign-in operation. So let's do it. So first of all, if I sign in with my real face.
First, let's share the screen. Can you share the screen? Okay.
So can you see it?
Not yet.
Sorry.
It's okay. And you guys, I'd like to thank you as well for participation in the discussion. We had amazing questions here, and we'll try to answer them actually after the webinar as well, if you're really interested, because this video will be available also after the webinar. So you can watch it anytime. We're going to do also follow-up emails. So you can watch it. You can still keep asking us questions. You can see down here the call to action button where you can write us anytime. And in the meantime, Daniel worked out the passive liveness. So let's.
Okay. So hopefully you can see my screen now. This is my phone. Okay, the screen is on. So again, I will do the sign-in operation. If I do it with my face, should get into quite straightforward. You could have seen the short time when the app was connecting the server. Currently, the passive liveness check is evaluated on the server, but we are actually also transferring this technology to the device itself. So I'll try to show you also the on-device version. And again, I will try to use my fake image. So, okay. And you can see liveness check failed. So that's it. As I said, this was the server version. Let's try also the on-device one. There are still some things that we need to polish, but let's test it. Okay, so fast. Once again, with the fake. See? So that's it.
Awesome. Thank you very much, Daniel. Thank you also for the presentation. It was great.
You're welcome.
And thank you everybody for joining the webinar. Hope to see you soon. Bye.
Bye-bye.